You are floating, alone. Your suit is a small, glowing beacon against an impossible backdrop. You look out. Ahead, there is a place where the universe seems to stop. The stars, familiar, friendly points of light, begin to thin out. Entire galaxies, once vibrant swirls of dust and suns, fade like distant candles. You are drifting toward it, a silent, patient journey into the largest, darkest region we have discovered. It is a place where the cosmos holds its breath. There is a profound sense of quiet here. The hum of your life support is the only sound. This is not the violent, dramatic end you might imagine. It is not a black hole, not a cosmic monster tearing at the seams of reality. There is no fierce force pulling you in, no event horizon beyond which escape is impossible. This is different. Emptiness on a scale that defies comprehension. This is a cosmic void. More specifically, you are approaching the edge of the Boötes Void, a region so vast and devoid of matter, it challenges our understanding. A desert in the grandest sense, defined by what it lacks. The journey is not a fall, but a slow, inexorable drift into isolation. The feeling is immense, overwhelming awe. So, what exactly is this cosmic void you are drifting into? In the simplest terms, a void is a vast region of space with very few, or sometimes no, galaxies. They are the great underdense bubbles in the cosmic foam. Imagine the universe on the largest scales. It is not uniform. Instead, it forms a magnificent structure, the cosmic web. Long, thin filaments of galaxies, dark matter filaments, and massive nodes, galaxy clusters. The enormous empty spaces between them are the voids, the quiet, forgotten parts of the cosmic architecture. Their origin begins shortly after the Big Bang, about 13.8 billion years ago. The early universe was a hot, dense soup of particles, almost perfectly uniform, but not quite. Tiny quantum fluctuations, tiny density variations, seeds of everything. Gravity began to act on these differences. Slightly denser regions pulled in more matter over eons. Those regions became galaxies, galaxy clusters, and the filaments we see today. Gravity also pulled matter out of less dense areas. Those areas grew emptier over billions of years. A cosmic story of the rich getting richer, the poor getting poorer. Voids are the result of this gravitational sorting. They did not explode outward, they emptied as matter flowed away. Voids are a necessary part of cosmic structure, shaping the web. Not holes punched in the universe, but as fundamental as galaxies. Not true vacuums, just very low density, about a tenth of the cosmic average. Vast, silent deserts separating bustling cosmic metropolises. Understanding them reveals the universe's initial conditions and governing forces, the quiet half of the cosmic story. To truly grasp the significance of a place like the Boötes Void, we must attempt to wrap our minds around its almost unbelievable scale. Human intuition is built for the world we inhabit. Let us begin with our home. The Earth is a tiny sphere, just under 13,000 kilometers in diameter. It feels vast to us, but in the grand scheme, it is an infinitesimal speck. Our galaxy, the Milky Way, is a magnificent spiral disk. It stretches approximately 100,000 light-years. A light-year is about 9.5 trillion kilometers. Visual comparison. Earth, the Milky Way, and the Boötes Void, shown to scale. Now, let us consider the void. The Boötes Void, sometimes called the Great Nothing, is one of the largest supervoids we have observed. Its estimated diameter is a mind-shattering 330 million light-years. You could line up 3,300 Milky Way galaxies end to end. They would just barely span the diameter of this single empty region. If our Milky Way were at the void's center, our nearest galactic neighbor would be hundreds of millions of light-years away. From Earth, our night sky would be almost completely black. The familiar constellations and the Milky Way's band would be gone. This is what defines a supervoid, its sheer size. Even the Virgo supercluster would fit comfortably inside with room to spare. Voids represent the largest scale structures. They are not objects in the universe, in a very real sense. They are the universe, with galaxies as rare concentrations of matter. While we describe voids as empty, this term is relative on a cosmic scale. They are not perfect, absolute vacuums. There is still matter inside, but it is incredibly sparse and diffuse, like a faint mist spread across an enormous room. Normal matter and dark matter inside a supervoid like Boötes are only about 10% of the average density of the universe. A significant portion of the mass that does exist is dark matter, the mysterious, invisible substance making up about 85% of all matter. We cannot see it directly. We infer it from its gravitational effects, the rotation of galaxies and the bending of light from distant objects. Even in a void, this ghostly scaffold persists, but tenuous and spread out compared to dense galactic halos. Because so little mass is spread over such vast volume, gravity is weak and uniform. There are no large nearby masses to create a significant pull. An object at the Boötes Void center would feel almost no net gravitational force, only gentle, imperceptible tugs from distant galaxy walls, hundreds of millions of light-years away. There is another powerful yet subtle force at play, the expansion of the universe itself. Ever since the Big Bang, space-time has been stretching, causing distant galaxies to move away. This is not motion through space, but expansion of space. Imagine dots on a balloon. As it inflates, every dot moves away because the surface expands. In dense clusters, gravity overcomes expansion. Galaxies remain bound and orbit a common center. In low-gravity voids, there is little mass to counteract space-time stretch. As a result, the expansion is more effective in voids. Space inside a void expands slightly faster than in clusters. Over billions of years, voids grow, pushing the filaments and the walls of the cosmic web farther apart, sharpening the web's structure. This accelerated expansion is driven by dark energy, a repulsive pressure inherent to space. With weak gravity in voids, dark energy's effect becomes dominant. To a traveler inside a void, the distant galaxy walls would seem to recede with incredible speed. The isolation would grow as the universe accelerates toward a vast, lonely future. Imagine standing on a planet deep within the heart of the Boötes Void. Panoramic surface view under an almost perfect black sky. Tilt up. What would you see? The view would be profoundly different. On Earth, the sky glitters with thousands of stars. The luminous band of our Milky Way, a river of light. Inside the void, that spectacle would be absent. The sky would be deep, velvety black. No Milky Way band. No Andromeda. The constellations would not exist. With a powerful telescope, you might glimpse the distant walls of the cosmic web as a faint, ghostly glow, resolving tiny, dim galaxies at the limit of detection. The universe would look like a distant shoreline from the middle of a dark ocean. The cosmic microwave background would still be present, but invisible to our eyes. Any intelligent civilization there would see a fundamentally different universe. For millennia, they might believe they were alone. Discovering other galaxies would be a monumental, high-tech achievement. Their dark sky a constant reminder of isolation. What would actually happen to a human entering a cosmic void? Stripped of the science fiction tropes, violent portals, crushing forces, the reality is surprisingly gentle, though no less extreme. For an astronaut in a modern spacesuit, the environment is similar to deep intergalactic space. The primary threats are the same: hard vacuum, extreme cold, constant cosmic radiation. A well-designed suit and spacecraft protect against these, creating a habitable Earth-like bubble. Pressure outside is effectively zero. Your suit maintains internal pressure. Space is an excellent insulator, no air to conduct heat, so the suit must shed your body heat. Radiation is the real persistent danger. No magnetic field or atmosphere, high-energy cosmic rays and solar particles. One of the most disorienting aspects is the near-total absence of gravitational forces. In orbit, astronauts freefall in Earth's grip. Here, you are truly adrift. The gravity from matter at the edges is infinitesimal and balanced. You would feel no up or down. You would be a perfect inertial reference frame, floating in sublime stillness. There would be no tidal forces to stretch or squeeze you. The psychological impact may be the most significant challenge. Humans are not wired for absolute solitude and sensory deprivation. Surrounded by complete darkness, with no familiar celestial landmarks, the feeling of smallness intensifies. Yet for some, it could be unparalleled peace and wonder, a solitary point of consciousness in a sea of nothingness. It is the ultimate journey into the heart of cosmic silence. The discovery and study of the Boötes Void, and others like it, is a triumph of modern observational cosmology. We cannot simply look and see a void. We map them by charting galaxy positions via redshifts, measuring how fast they recede to estimate distance, building a three-dimensional cosmic web. Identified in 1981 with sparse data, the Boötes Void seemed almost empty. Deeper surveys revealed a few scattered, lonely galaxies, yet it remains astonishingly underdense. The James Webb Space Telescope can study faint void galaxies in unprecedented detail, revealing star formation in pristine environments. Upcoming surveys like the Vera C. Rubin Observatory and Euclid will map billions of galaxies, charting the shapes, sizes, and interiors of voids with breathtaking precision. By measuring void shapes and their lensing of background light, scientists test general relativity, dark matter, and dark energy on the largest scales. Voids probe the history of cosmic expansion and the forces that govern reality. They are not just empty spaces. They are cosmic laboratories. In a universe this vast and empty, what does that say about our place within it?